Good morning, everyone. This is your teacher, Miss Rita. I hope that you are all staying safe and I miss you so much. Today, we will continue explaining Lesson 8 Solutions. Today's objectives are first to summarize the lesson and then solve some exercises. So we previously said that a solution is made up of two parts, which are solvent and solute. And the solute is the substance that dissolves in the solvent. A solution, which is a homogeneous mixture, can be of three types. It can be a liquid solution, a solid solution, or a gas solution, and all of these are based on the state of the solvent. So if the solvent is solid, it means that the solution is a solid solution. If the solvent in a solution is water, then this solution is called aqueous. And if not, then we call it non-aqueous. A solution can be either concentrated or dilute based on the amount of solute. If it has a big amount of solute, we call it concentrated and it will have an intense color. And if it has a small amount of solute, then we call it a dilute solution and it will have a light color. We can change the concentration of a solution. We can make it more concentrated or more dilute. To concentrate a solution, we can do two things. First, we can add more solute, or we can decrease the volume of the solvent by vaporization. To dilute a solution, we can do the opposite. We can add more solvent or mix a smaller amount of solute. Finally, we learned that we can calculate the concentration of a solution by using the following triangle. So the concentration is equal to the mass of the solute divided by the volume of the solution. And usually we take the mass in grams and the volume in liters. Page 124, number 4. A student conducted two experiments and these experiments are not related to each other. So in experiment 1 we have 3 beakers A, B, C, and in each beaker we have different components. Based on the given we have to answer parts A, B, and C. So in beaker 1 we have copper sulfate and distilled water. Together they form one phase, which means it's a homogeneous mixture. In beaker 2 we have vinegar and distilled water. They also form one phase and they are a homogeneous mixture. However, in beaker C we have sand and distilled water. These two do not mix, so they form two phases and they are a heterogeneous mixture. Part B. Which of the above mixtures are solutions? Justify your answer. So of course mixtures A and B are solutions because they form one evenly spread phase. However, beaker C is a heterogeneous mixture, which means it's not a solution. Part C. Are these solutions aqueous or non-aqueous? So they are aqueous because water is their solvent. In experiment 2, the student prepares 3 solutions and you have the components of each solution. Based on this, we have to fill the table. So in solution 1, the solute is salt. The physical state of the solute is a solid. The solvent is water. The physical state of the solvent is a liquid. Therefore, the physical state of the solution will also be a liquid because it depends on the state of the solvent. And we did the same for the rest. In solution 2, alcohol is the solute because it has a lower volume or a smaller volume than distilled water. Part E. Does the physical state of a solution depend on the physical state of the solute or on the physical state of the solvent. So we already covered this. We said that the physical state of the solution depends on the state of the solvent. Please make sure to copy all the answers on your copybook. Now, as homework, I need you to solve page 127, number 5.